All right, here we go. This is some practice for Algebra 1A. We are going to be solving one-step equations. Solve one-step equations. And so, of course, the equations can get much more complicated than one-step equations, but we'll start with this. So I'm on IXL. This is, as of the making of this video, this is a new link on Canvas. But you can see the IXL assignment what we're doing here. And yeah, we're going to solve for h in this equation. So I'm just in my kind of scratch space here. I'm just going to rewrite this. So the trick here is to recognize that if we zoom into the side that has the variable on it, we are given division. We're given division by 3. And I'm not gonna do 3.5 divided by 3. I'm going to try to cancel division by 3. So to cancel division by 3, I'm going to multiply by 3. So when I do that here, the division and the multiplication by 3, those are inverse operations. If you do both of them, they cancel, and you're left just with h, and that's what we wanted. But now I have to balance the equation, so I have to also multiply the other side. I got to do the exact same thing, multiply by 3. Okay. I got my calculator handy here. This is more difficult than what we usually do in class, but we get to use the calculators. So I get h on the left, I got 10.5 on the right. Now I can certainly type that into IXL, but what I have the power to do though is to check for myself if this is a good solution, if this value 10.5 is a good solution. So if I take the 10.5 and I put it in for h, is 10.5 divided by 3, I'm supposed to get 3.5. Is that true? So again, I can use my calculator. I got the 10.5. If I divide that by 3, calculator says 3.5. So the equation then says 3.5 equals 3.5. That is true. So I go, hooray. So I like my answer of h equals 10.5. So let's type that in here. 10.5. And we got it. Cool. So we're off and running. This is another division problem. So I'm going to go kind of quickly with this one, very similar to the last problem here. Let's see here. So again, I'm given division. I'm not going to do 4.2 divided by 3, even though that works out nicely. I think it's 1.4. I go, the equation does not say 4.2 divided by 3. It says s divided by 3. So I say, well, hey, guess what? I can cancel that if I multiply by 3. Multiplying by 3 and dividing by 3 cancel. Balance my equation. Do the same thing on the other side. And s on the left. And grab the calculator if you need to. That'd be, I think it's 12.6. 12.6. But let's check this. And let's take that 12.6, let's put it there. If we do 12.6 in the original equation, if we divide that by 3, do we get 4.2? This is the check step. So calculator, 12.6 divided by 3, yeah, I get 4.2. It says 4.2 equals 4.2. I go, hooray, I like it. So that's a good answer. Let's type that in. 12.6. Whoops, I put a comma. Okay, whoops. So that was a typo. Not 12, comma 6, 12.6. I got it, IXL. Thank you. All right, another division one. Let me skip around here. Let's see what else we can find. Another division one. Another division one. Another division one. All right, let's jump backwards here. These are all division ones. What's going on? Well, maybe they just want me to do a division one. All right, I guess we'll do a division one. We'll do this one. Okay. So I'm going to cancel the division with multiplication. This one I don't like as an example because the 2's could get confused which 2. But because of this 2 over here, I'm going to multiply by 2. I'm dividing by that 2. I'm going to multiply by 2. Cancel that. Balance the equation. Multiply by 2 on the other side. 2 times 2 is going to be 4. And j there. And that one I think is a pretty quick check step. We know if you do 2 does equal 4 divided by 2. I think we know that one. So 4 is my answer there. Let's type it in correctly this time. There we go. All right, here we go. Here's one that's not division. But I'm still going to try to cancel things here. So we got 8.09 plus h plus 6.09. All right. Whoops, there's an equal sign here. Just the equal sign. Eraser. There we go. Equals. All right, so now if I think it through, again, I'm not adding 8.09 plus 6.09. Read the equation, understand what it means. The equation says 8.09 is the result of some number h added with 6.09. I don't add the two numbers I'm given. That's a common mistake. What I can do, though, is I can cancel the addition. I can say, let's subtract that 6.09 to just leave ourselves with h. Adding 6.09 and subtracting 6.09 are inverse operations. Now I have to subtract 6.09 over here. So on the left side, I believe that's just 2 with no decimal. The right side, I had a hamburger, $6.09. We took away $6.09. And we've got h equals 2 or 2 equals h. So now the check step, the all-important check step, if I put that 2 right there, would that work out? Would 8.09 be the result of 2 plus 6.09? And now when I'm quite certain it is. Is that true? I'm quite certain it is. You can double check on the calculator if you want to, but 2 seems like a good answer. Let's type that in. So it's all about canceling things. All right, here, good. This is a different one. 2t, let's see here, 2t equals 8.6. So make sure you recognize this is 2 times t. That's really what this is about here. This is 2 multiplied by t. Whoops, 2 times t, not 2 times 2. 2 times t. So I'm given multiplication. I go, thank you, but it's not 2 times 8.6. It's 2 times some number. And I'm told what the result is. I'm told what the product is. So I can cancel that if I divide by 2. 2 tomatoes split into 2 equal groups. Each group would be 1 tomato. That's what I want. I just want 1 tomato. Now I got to divide the other side by 2 as well. So 2t divided by 2 is just 1t, or t. And grab the calculator if you need, but that one I'm pretty sure is 4.3. So that's our answer, but let's check this before we put it into IXL in case if I get it wrong, then my score would drop. If I put the 4.3 right there, 2 multiplied by 4.3, that is supposed to equal 8.6. Is that the case? Is 2 times 4.3 equal to 8.6? Grab the calculator if you need to, but this does work out. 8.6 equals 8.6. That is what we were hoping. So 4.3 is a good solution. 4.3. All right, let's see if we can get, here's another division one. Let's see if we can get one that has subtraction in it. So I'm jumping around. By the way, in case you're wondering how am I jumping around here, I'm logged in as a teacher, and so I have that privilege that I can just jump around here. Well, let's see. They're not giving me any subtraction ones. I'm gonna pause it here to see if I can get a subtraction one. Okay, took me a while, but I finally found a subtraction problem where they give me subtraction. So let's see here. How are we going to do this? So we have Q. We're subtracting 969, and the result of that subtraction is negative 835. So once again, I am not subtracting the given numbers. I'm going to try to undo that subtraction. I'm going to try to cancel that subtraction. So what would cancel subtraction with subtraction of 969 if I add 969? That's going to cancel, leaving me just with my variable. Now I have to balance. I have to come to the other side and add 969. And that's where you can grab the calculator there. Let's see here. It's not cheating, even though my stepdaughter might say so. I get here 134 when I do that. So let's check. If we put 134 here and we subtract 969, do we in fact get negative 835? All right, calculator, 134 minus 969, and my calculator does say that this is negative 835. So I always like to just write this equation, that it says the number equals itself. I go, hooray, so there we go. So 134 would be our answer. Let's type that in, and there we go. All right, I'm going to see if I can try to find maybe one more. Yeah, we'll do maybe one more example here. Okay, I think this is the last problem I'll do here for this video. This is one even my veteran math students will make a common mistake on this one. So I'm gonna show you how to do it correctly, and then I'm gonna show you a couple mistakes, and then we'll demonstrate the power of the check step. So let me write this out here. So we've got negative 84 equals negative 7v, and again, to recognize that what we're given here, this is negative 7 times v. So I can't perform that. If you don't tell me the value of v, I can't tell you what negative 7 times v equals, except, well, here I'm told that it's negative 84, but I'm supposed to figure out what v equals. So I'm going to cancel multiplication with negative 7 using division with the exact same number. I want to get positive 1v. And if you remember, negative 7 divided by negative 7 is a positive 1. So if you sneak a v in there, it's positive 1v, which is 1v, which is v. So that's what I want. So I'll show you some common mistakes here that even experienced math students will do. But okay, so when you divide by negative 7, multiplying and dividing by the same number cancels. I'm left with positive 1v on the right side, or v. And then on the left, grab your calculator if you need, but I'm pretty sure that's positive 12. So it says positive 12 equals v. So let's check that. If we put a positive 12 right there, do we get a true equation? Is negative 4 equal to a negative 7 times positive 12? Again, grab your calculator if you need to, but yeah, this works out. Negative 84 on the left, negative 7 times 12 is negative 84. That's true. So this is a good solution. Okay? So I'm going to show you a couple mistakes. We'll put this in, but before this goes away, I want to show you a couple mistakes that students will commit. Mistake number 1. So here's mistake number 1. Students will do this. They see that negative 7 and they just automatically want to add. So that's what some students will do. They go, hey, let's add 7 on both sides, and they think that cancels. And I understand, like if it was v minus 7 and you added 7, yeah, that would cancel. But v minus 7 is when you're subtracting 7. Negative 7v, you're multiplying. So addition never cancels multiplication. That's one thing to realize. Addition does not cancel multiplication. The other thing to realize is that over here, those would not be like terms. When you're trying to add or subtract, you have to be careful about like terms. It would be like, I owe 7 violets and we're giving $7. I go, that doesn't make it 1 violet. But let's follow through with it. Let's follow through here and pretend that it was correct. And we think we get V. And on the left side, grab your calculator. I'm pretty sure that'd be a negative 77. I'm just going to double check here. I should know this, but yeah, negative 77. Now, if you check this, though, this is the importance of the check step, ladies and gentlemen. Negative 84, if you put that negative 77 there, negative 7 with, I'm not putting addition or subtraction in because there's no addition or subtraction here. But I put that negative 77, and then I go, oh, it's multiplying. And I take negative 7 and I multiply it by 77. I get positive 539. The equation says negative 84 equals positive 539. I go, whoa, no, not even close. That's false. Okay, but again, the mistake there was adding does not cancel multiplication. So that's mistake number one. A lot of students make that mistake. The other mistake that even experienced math students will commit, we'll call it mistake number two. So again, this is a mistake. They'll recognize it, go, yeah, I know it's multiplication. So let's divide. But then for some reason they divide by a positive 7. And I think it's just where they get mixed up with, like, I need a positive to cancel the negative. Well, they are dividing to cancel multiplication. But if you think about this, if you did negative 7 divided by 7, that would be a negative 1. And then if you say, but it's really negative 7v divided by 7, that'd be a negative 1v. You would owe a violet or whatever v represents. I go, I don't want to owe 1. I want to have 1. I want positive 1v. But let's just follow it through, because maybe we're not sure. So we divide by negative 7 on both sides. We think this cancels, even though it doesn't give us just 1, positive 1. But let's follow through with it. Negative 84 divided by 7, that'd be a negative 12 if we think it's v over here. And then if we do that check step, all right, let's check here. Is negative 84 equal to negative 7 times our value of negative 12? Is that true? Well, hopefully you remember already that a negative times a negative is a positive. So this would be a positive 84. And I go, no, that is false. It looks so close. But one of them I owe and the other I have. Do I have $84 or do I owe $84? So again, we're going to divide by the exact same number. This is what we're doing over here. We're dividing by the exact same number to get a positive 1v, which is 1v, which is v. So 12 is my answer there. I'm just going to put this in, make sure, even though I've checked it several times here. All right, so there we go. So I'm going to end it there. But yeah, practice with this, practice, because equations get a lot more difficult. So just having this basic understanding of I'm not going to perform the operation that's given to me, I'm going to cancel the operation that's given to me. Okay. Hope that was helpful.